Taman Sri Muda is located in Section 25 of Shah Alam, Selangor, Malaysia. Has faced significant flood-related challenges over the years. The area is particularly vulnerable due to a combination of geographical, environmental and infrastructural factors. For the geographical, Taman Sri Muda is situated in a low-lying region, making it prone to water accumulation during heavy rainfall. The area is near the Klang River and other smaller waterways, which can overflowing during periods of intense rain. The increasing frequency of heavy rainstorm linked to climate changes has exacerbated the flooding issues. The draining infrastructure in Taman Sri Muda has been unable to cope with the volume of water during heavy downpours. Siltation and inadequate maintenance further reduce its effectiveness. Urbanization in and around Shah Alam has led to increased surface runoff, with less land available to absorb rainwater. While some measures have been implemented, they have often been insufficient to handle the scale of flooding experienced in the area.
Hi, my name is Nur and Benturstam. My number is CF22002, and I'm here to explain the objectives of our project and give some context to the problem we are addressing. So, let's start with our objectives. The first one is to develop innovative strategies to deal with flooding in Taman Sri Muda. Instead of relying on traditional methods, we are aiming to come up with solutions that are both creative and effective. Next, we want to promote teamwork and strategic thinking by working together and combining our ideas in hopes that we can to approach the problem from different angles and find the best possible solutions. And lastly, our goal is to ensure the solutions we design are practical and sustainable. We don't just want to solve the immediate problem, we want to create something that will work long term and adapt to future challenges. So now, let me walk you through the problem we are addressing. The flooding in Taman Sri Muda is caused by a mix of factors, such as heavy rainfalls that overwhelms the drainage systems and high tides make it hard for the water to flow out to the sea, leading to backflow in lower areas. And on top of that, control releases from dams upstream can also raise water levels even more. Urbanization has made things worse by reducing natural areas that can absorb water, which increases surface runoff undeniably. The impacts are serious. Flooding damages home, businesses, and infrastructure. It displaces families, and stagnant floodwaters can create health risks like waterborne diseases. It also disrupts the local economy, especially for small businesses and agriculture. But the most affected areas are the low lying neighborhoods, places near rivers, and key infrastructures like roads and also hospitals. So, this thing makes it very clear why we need targeted and innovative solutions to prevent these issues in the near future.
Next, for first proposed solution, first one is widening and deepening the drains. The existing drains in Taman Sri Muda are often too narrow. Second is constructing retention ponds. The retention ponds are essential for managing excess rainwater. Lastly, improve drainage gradient. Ensuring that drains have the correct gradient is crucial for efficient water flow. Drains that are too flat can cause water to stagnate, while those with too steep a gradient can lead to erosion. Proper engineering assessment should be conducted to design drains with optimal gradients.
Assalamualaikum and hi, my name is Muhammad Fidaus Amin. My metric number DF220144. I will be presenting on second proposed solution for flood mitigation. So, I will present about the flood alarm system, which is a proactive solution designed to provide early warnings in flood-prone areas like Taman Sri Muda in Shah Alam. So this system aims to enhance community safety and preparedness during heavy rainfall events. So, the system components consisting of three components, which is flood sensors, which is and communication module, and also central control unit. So, for a flood sensor, these are the core of the system. We use water level sensors such as ultrasonic sensors to detect rising water levels in real time. So, they will be placed in low-lying, flood-prone areas for early detection. In communication module, a GSM module sends alert via SMS to residents and local authorities when water levels reach critical threshold. This ensures timely notifications for evacuation or other necessary actions. In central control unit, an Arduino or a similar microcontroller processes data from the sensors and triggers alarm or notification based on water level readings. In site assessment and system development, we can see that site assessment so that we can conduct a detailed survey of Taman Sri Muda to identify critical areas for sensor placement, such as drainage outlets, riverbanks, and low-lying streets. In the system development, this system will be built using ultrasonic sensors, which is to measure water levels, GSM modules for sending alerts, and microcontroller to process sensor data. In testing and calibration, so once it's installed, we'll test the system to ensure it works correctly. We will calibrate it to set appropriate warning such as normal warning and danger levels. Okay, let's move on to integration with emergency service. Lastly, we'll focus on integrating the system with emergency service such as collapse with local authorities. We will work with emergency services to ensure they receive alerts directly from the system. This will enable quick actions like rescue operation or evacuation planning. It is also a real-time monitoring dashboard. Each centralized dashboard will be developed for local authorities to monitor real-time data from all sensors. This will provide a clear view of flood risk across Taman Sri Muda and can help in decision making. So, I will conclude that our flood alarm system combines advanced technology with real-time monitoring to provide timely alerts, reduce flood risk, and improve safety in vulnerable areas like Taman Sri Muda. Thank you.
The major flood that struck Selangor in 2021 was a tragedy that had a significant impact on society, the economy, and the environment. Additionally, the disaster caused by continuous heavy rainfall due to extreme weather phenomena such as the monsoon surge and tropical depression resulted in widespread destructions, including loss of life, damage to property, and the displacement of thousands of residents. This tragedy also exposed weaknesses in disaster management system, urban planning, and public awareness of flood risks. Therefore, immediate improvement must be implemented to prevent similar incidents in the future. More sustainable urban planning should be enforced by prohibiting development in water catchment area and mandating flood mitigation measures in development plans. Environmental laws must also be strengthened to prevent illegal logging and land clearing which contribute to soil erosions and uncontrolled water flow. Additionally, the flood warning system needs to be enhanced using modern technology such as mobile applications and SMS to provide early alerts to residents in high-risk areas. Public education is equally important to raise awareness about flood preparedness and safety measures. At the same time, strong cooperation between government agencies, local authorities, and communities must be reinforced to ensure a more efficient and effective disaster response. Finally, post-disaster financial aid and psychosocial support should be provided to help victims rebuild their life.